My name is Marsha Umairah binti Muhammad Zamiri, and I'm going to talk about the method and the discussion for this experiment.
Assalamualaikum and hi. My name is Sharifah Sofia Nisa binti Said Mubarak Aswad.
Hi everyone, my name is Nur Kristina Batrisha binti Zana Abidin.
Assalamualaikum, my name is Nuriana Maisara binti Muhammad Kamar Zaman.
Hi, I'm Nur Kristina Batrisha binti Muhammad Yusri. So, the objectives in this experiment are to determine the volume and density of ball bearing and to determine the volume and density of glass block.
Introduction or theory of this experiment is the vernier caliper is an instrument that can measure external thickness, internal diameter and depth hole to a maximum of 130 mm with a 0.05 mm approximation. This instrument has a mean scale and a sliding scale that allows readings of objects to the nearest 0.02 mm. The vernier caliper can be used to measure the outer dimensions of objects using the main jaws. To measure the inside dimensions, the smaller jaw at the top will be used, while the stem is used to measure depths. For measuring outer dimensions, the object should be placed between the jaws, which are then moved together until the object is secure. Each measurement will be precise and accurate if taken several times and then computing the arithmetic mean of the values. This is because the sample may only appear to be regular or it may deform when the caliper puts pressure on it. Thus, a better estimate of the measurement error can obtain by taking the difference between the minimum and maximum measure values. A micrometer screw gauge is used to measure even smaller dimensions than vernier calipers. This instrument uses an auxiliary scale to measure hundreds of millimeters, which is marked on a rotary thimble. This screw has an accurately constant pitch, which is the amount of the thimble moved forward or backward for one complete revolution. Besides, the jaws can be adjusted by rotating the thimble using the small ratchet knob. The jaws must be opened by 1 mm, which requires turning through 2 revolutions of the thimble. To measure an object, the object must be placed between the jaws and the thimble is rotated using the ratchet until the object is secure. Furthermore, the lock on the instrument can be used to ensure that the thimble does not rotate while taking the reading.
Method of experiment: micrometer screw gauge. First, the zero error was determined. The diameter of the ball bearing was measured. Step 2 was repeated at least 3 times at different positions of the ball bearing. Method of experiment: micrometer screw gauge. First, the zero error was determined. The diameter of the ball bearing was measured. Step 2 was repeated at least 3 times at different positions of the ball bearing. Method of experiment: next, all the data was recorded in a suitable table. The actual diameter reading was calculated taking into consideration the zero error obtained earlier. The weight of the ball bearing was determined. Lastly, the density of the ball bearing was calculated. Method of experiment: vernier caliper. First, the whole number of small divisions on the fixed counted part of the caliper that are to the left of the zero mark on the vernier. This gives the sizes of the objects to the nearest number of the whole millimeters. Next, the first mark on the vernier that line up with one of the marks on the fixed parts of the caliper was found. The value of the marks on the vernier then told how many fractions of millimeters were needed to complete the estimate of the size of the object. The zero error of the vernier caliper was determined. Next, the length, width, and thickness of the glass block was measured by using the vernier caliper. Step 2 was repeated at least 3 times at different positions of the glass block. Method of experiment vernier caliper. First, the whole number of small divisions on the fixed counted part of the caliper that are to the left of the zero mark on the vernier. This gives the all the data was recorded in a suitable table. The actual measurements was calculated by taking into consideration the zero error obtained earlier. The weight of the glass block was determined. Lastly, the density of the glass block was calculated.
To measure the diameter of the ball bearing, you have to use micrometer screw gauge, and you have to calculate its volume. To calculate its volume, you have to use this formula. To measure the length, width, and height of a glass block, you have to use vernier caliper, and to determine its volume, you have to use this formula. To calculate the density, you have to use this formula. And first of all, we're going to calculate the ball bearing, the density of ball bearing.
So, for the discussion, a micrometer screw gauge and vernier caliper were utilized to measure the diameter of a ball bearing and the length, width, and height of a glass block. Next, a micrometer screw gauge accurately measured the diameter of a thin wire or metal sheet with a known pitch of 0.5 mm. Next, the screw pitch is the distance the spindle moves per revolution with a 0.5 mm change in pitch for one screw revolution. The micrometer screw gauge has a sensitivity of 0.01 mm with a linear millimeter scale on the sleeve and a circular scale on the thimble.
In conclusion, our experiment on determining the volume and density of a ball bearing using a vernier caliper and a weighing scale has been done. We measured the diameter, corrected for zero errors, and calculated the average. Using the sphere volume formula, we determined the volume. We then weighed the ball bearing to find its mass and calculated its density. Performing basic measurement experiments is crucial for more advanced studies and research, ensuring accuracy and precision in one's work. For people in general, understanding basic measurement techniques fosters a better appreciation of science and its application in everyday life. Overall, our experiment was successful and we gained valuable insights into measurement techniques. By addressing sources of error, we ensured our results are reliable and valid.